Hey everybody, we're live and in studio. This is a question that has been tested in your exams, and I want to quickly go over it because there are multiple methods to go over such questions, right? The first way is to go over it through the method that I have taught you, or the other way is to go through it through the idea of delta H formation. So you're asked about the enthalpy change of formation of SCl2, right? First of all, let's write the equation for it. You know that S8, sulfur is in its solid state, right? Sulfur in its standard state is S8. So S8 solid reacts with chlorine and gives you SCl2. And since this is the enthalpy change of formation which we need to find, everything else must be balanced. This should be 1 mole because enthalpy change of formation is 1 for 1 mole of a substance forming from its elements in its standard state. So this is chlorine gas. This is supposed to be a solid or a liquid. It's going to be written in the exam. Solid, like a liquid. Sorry, it's a liquid. My bad. It's a liquid because see, it's written right here, SCl2, that's liquid, right? And then S8 plus Cl2, and then you just balance this stuff out. It's 1 over 8 right here. And that's good stuff, right? So this is what I need to actually find. Now, the idea is pretty simple. Use Hess cycle the way I've taught you to use it. See, you have S8 here, you have S8 here. This should be my starting point, right? 3-box diagram. This should be my starting point, right here. S8 should be my starting point, right? And what should be my ending point? See, you are here with SCl2 right here and SCl2 right here. Remember the complicated questions that I did at the start? So SCl2 should be the end point, and what should be the intermediate? S2Cl2, right? True. S2Cl2 should be the intermediate. Now, this is what I need to calculate. See, S8 plus chlorine going into SCl2. You can write chlorine here. I couldn't care less, right? So S8 going into Cl2, this is X, I don't know. But S8 going into S2Cl2. What's that equation? See, S8 going into S2Cl2. The equation for that is minus 58.2, right? So it's minus 58.2. But please be very cautious here. Be very, very cautious. The thing that you need to be cautious about is the idea that S8 going into S2Cl2 is for 4 moles. This energy is for 4 moles of S2Cl2 forming. So I won't just write S2Cl2 here. I'm going to write 4 moles of S2Cl2 forming. True? Everybody agrees with me, right? 4 moles of S2Cl2 forms, right? This is the enthalpy change, because see, this is the enthalpy change of the reaction. Reaction is just when they react in their molar coefficients ratio, right? So it's for 4 moles of S2Cl2 forming, this energy is given out. So I have written this, see, for 4 moles of S2Cl2 forming, this energy is given out. No need to mingle with this right here. Now, 4 moles of S2Cl2 will form how many moles of SCl2? S2Cl2 going into SCl2, S2Cl2 going into SCl2. What's this energy? This energy is minus 40.6, right? But please be very careful. Be very careful. See, this is minus 40.6, and this is the enthalpy change of reaction. So it's as per their molar coefficients, right? So it means 1 mole of S2Cl2 will give you 2 moles of SCl2, and the enthalpy change for the reaction is minus 40.6. 1 mole gives me 2 moles. 1 mole gives me 2 moles, and this is the enthalpy change of the reaction. But 1 mole gives me 2 moles of SCl2. Please understand. How many moles would 4 moles give you? How many moles of SCl2 would 4 moles of S2Cl2 give you? Shabash. See, if 1 mole gives me 2 moles, and the enthalpy change of reaction is this much, if you have 4 moles of this, how many moles of SCl2 would form? Shabash, shabash, shabash. How many moles of SCl2 would form? Sir, SCl2 moles would be double. It would be 8, wouldn't it? It would be 8, absolutely, right? And see, the enthalpy change of reaction when 1 gives you 2 is this much. So if 4 gives you 8, what would be the enthalpy change of the reaction? What would be the enthalpy change of the reaction? If 1 gives you 2, right? The enthalpy change of reaction is minus 40.6. But if this is 4, this is multiplied by 4. The enthalpy change of reaction should be what? It should also be multiplied by 4, right? True? Everybody agrees with me? Now calculate X, everybody. I wanna make this crystal clear. See, the indirect root equals the direct root. So X equals, it's a piece of cake now. X equals minus 58.2 plus 4 times minus 40.6. Everybody, can you guys calculate X? This X is not the final answer. Please understand. It's not the final answer. What is X? Anji, what's X? Shabash. This is one thing you need to be careful of. That's it. Achha, this is not 40.6. Okay, it is 40.6. I thought it was 90.6, but it is 40.6. Achha, what do you get? Everybody, please help me out. Somebody. It's minus 220.6, right? But please understand, this X is minus 220.6 for 8 moles of SCl2 forming. You need what? You need 1 mole of SCl2 forming. This is for 8 moles. See, 8 moles of 8 moles of SCl2 forming. But delta H formation for SCl2 is for 1 mole of SCl2 forming. This enthalpy change that you've calculated is for 8 moles. What should I do with it? What should I do with this enthalpy change? It's for 8 moles. I need it for 1 mole. What should I do with it? Shabash. Shabash, what should I do with it? Help me out. This for 8 moles. I want it for 1 moles. Divided by 8. That's it. So what do you get, sir? Minus 27.6 kilojoule per mole. This is the enthalpy change of formation, right? And so this is the idea that I promoted at the start of the class. You know, the first couple of questions that we did it with the same idea. The only difference is that in these questions, the questions that I did, and in this particular question, these moles ratios are different, right? And so the idea is the same all along. Just need to be very careful that when S8 goes into S2Cl2, the enthalpy change of reaction is minus 58.4.2, but that is for 4 S2Cl2 forming. So I have to write 4 S2Cl2 right here, and this is minus 58.2. Right? Because reaction has to do with however many moles are present. It has to do with however many moles are present. It's not enthalpy change of formation, is it? It's reaction. Formation should have been for 1 mole. It's reaction. Now, if some students are quick thinkers, let's talk about how they could solve it, you know. And I would not recommend this because, you know, I don't think all the students would be able to decipher this in the exam unless and until they've rote learned this idea, which is the fact that they could do this. Wait. And this is that idea, guys. Let me show it to you. See. The other idea of doing this is to use a lot of brain, or if you remember it, it's totally awesome. But if you want to figure out the enthalpy change of formation of SCl2, right? You want to figure out the enthalpy change of formation of SCl2, and you're given just this particular equation. You don't like writing equation, and you're given this particular equation. What you could think like is, hey, I could figure out the enthalpy change of formation of this fella, and I could figure out the enthalpy change of formation of this fella from this particular one reaction. So what do you mean? Write S2Cl2, and then write the same equation, right? S2Cl2 going into 2SCl2, right? S2Cl2 going into 2SCl2. And what is the enthalpy change for it? The enthalpy change of reaction is minus 40.6. And you could just write elements right here. Now see, this requires a bit of knowledge, a bit of quick thinking. And I don't think students would have it. You know? If they do, it's good stuff, right? So elements. What is the enthalpy change of formation of S2Cl2? That's what you should ask yourself. How do you calculate the enthalpy change of formation of S2Cl2? See, you're given the enthalpy change of reaction, but you realize if I divide the entire reaction by 4, and I never ever recommend this method because students get confused hell of a lot, right? So it doesn't really matter. But hey, if you can think like this is good. If you divide the entire reaction with 4, you will actually get what? The enthalpy change of formation of S2Cl2, because enthalpy change of formation is for 1 mole of a substance forming. So I'll divide this entire reaction by 4, and therefore the enthalpy change should also be divided by 4. So this would be minus 58.2 divided by 4 right here. And this right here, how do I find the enthalpy change of formation of SCl2, sorry. I know that this particular fella right here is going to be 2 times because there are 2 moles, right? So this should be 2 times the enthalpy change of formation of SCl2, right? And then you could figure out this enthalpy change of formation like this, right? So this is the other method for it. And frankly speaking, it's up to you. The indirect root equals the direct root. So minus 58.2 divided by 4 minus 40.6 equals 2 times x, which is the enthalpy change of formation. X equals, and you could figure it out. Whatever the answer is, it'll be still minus 27.6. And you could check it out. It will be minus 27.6. You could solve this and then divide by 2. You will get the same answer. Now, it's up to you. If you can use this brain in the exam, good for you. If you can't, then just stick to the idea which I've taught you to solve complicated question when you have enthalpy change of reactions available. You could easily solve them. Just make sure to be very careful of these modes, right? So it's lengthy, but there's no rote learning here. And I hope there's no rote learning here. If you can think like this, it's good for you. Take it. Done.